All right, we get to talk about immune function. Behind me here is what's called the Dancing House. It's in Prague. So it's kind of a fun building to go take a picture at. But if you notice, the colors of it are kind of warping my ear over here on this side a little bit off and on. Hopefully that won't be too distracting. I'll move a little bit more into the light here in the room. Maybe that'll help to make a difference. All right, so immune function, and even though this says immune system, officially the immune system is not one of the body's systems, and that's because immune function is actually spread throughout many different body systems. But so when we talk about the immune system, it's not one specific thing, it's really just the way things work. So as we talk about the immune system here, it's broadly categorized into non-specific defenses, or sometimes you hear these called the innate immune system, because you're born with it, right? You don't have to do anything, you have these things. And then there's the specific defenses, which is also called the adaptive or adaptive immunity, because it adapts to the specific pathogens with which you would be infected. So non-specific defenses, these are the things that you just have. It doesn't matter what pathogen is coming at you. These things will help to fight it. So I like to think of, if you have an ancient city and it's got this wall built around it, it doesn't matter, what invader is coming to get into the city. That city wall is going to help keep them out, right? And that's like our skin and our mucous membranes. So the linings on the inside of body cavities, the digestive tract, the respiratory tract, inside your mouth, and in other areas. So they have these mucous membranes, and both of these help to provide defenses. Leukocytes, or white blood cells, except for lymphocytes, well, two of the three, which are really more involved in specific immunity. A fever, a high fever can help prevent the spread of infection in the body. And so it's nonspecific. Inflammation is nonspecific. And there's also just some antimicrobial proteins that we have. These are all around and just kind of do their job no matter what pathogen is trying to infect you. Specific defenses, we're going to start with lymphocytes, which really make up the core of this here. And we broadly categorize that into T cells and B cells, or T lymphocytes and B lymphocytes. And just some simple facts about them, they're both made in red bone marrow. But T cells go to the thymus where they mature, and that helps it to be easy to remember because thymus starts with T. Whereas B cells stay in the red bone marrow to mature, and we can remember that as well because B starts with, or bone starts with B. After they become mature cells, meaning that they have receptors to the antigens, they're all in place in the cell membrane, those T cells and B cells then go to the lymph nodes, the tonsils, the spleen, and a few other sites. But in general, these are known as lymphatic organs. Again, primarily because that's where lymphocytes would be found. So what we're going to do now is talk a little bit about the difference between function of T cells and B cells. So T cells, and this is, by the way, very simplified, but it's basic. A T cell is going to be able to recognize an antigen. And usually it does that because there's another, the sequence is a little more complex. There's another cell that will recognize and present it to the T cell, but ultimately the T cell figures out, hey, there's an antigen. And I know that that doesn't belong here. And so in response, the T cell divides and multiplies. Some of those T cells will become cytotoxic T cells, and they're going to go out and destroy the pathogen. And they have multiple ways of doing that. There's different things that happen. Some of those T cells will become helper T cells. Those helper T cells are important because they actually help to activate, it says activate helper T cells. This is incorrect. That should say, I must correct it right now, help activate the cytotoxic T cells, the ones that we just talked about. So both types of T cells get made, but the helper T cells actually help to activate these cytotoxic T cells. They will also help to activate the B cells that we'll talk about in a moment. They also help to activate macrophages, which are needed to come in and chew up and spit out the pathogen. and that's kind of how they get destroyed. And then finally, some of these T cells also become memory T cells. Okay? They really don't do anything right now. They just sit around and wait for the next pathogen to have an infection here, or something similar to it. B cells also will be able to recognize an antigen through different mechanisms, but they're going to work a little bit differently in that these B cells ingest the antigen and then they destroy it. But that's not it, because that's only one cell and one antigen. Remember, the helper T cells actually help that, so I have they're coactivated by the helper T cell here. Now in response, when they ingest and destroy that antigen, now they multiply and divide. And this is an important part of immune function, is the cells multiply and divide. And some of those cells will become what are called plasma cells. And sometimes when I teach this, I prefer to call them plasma B cells, so students specifically know I'm still talking about B cells. Well, these plasma cells, they secrete antibodies. That's the job of these activated plasma cells. What do antibodies do? Again, a number of ways in which they work, but basically they're going to neutralize that pathogen. They're going to find a way to stop it from being detrimental to the body. They will also kind of tag the pathogen. And if you've ever been in the woods where they've tagged trees that have disease so they wouldn't cut them down and get rid of them, this is kind of the same idea. The antibodies tag the pathogen, and then there's other cells that will recognize that and come over and actually destroy those pathogenic cells. Just like the T cells, some of the B cells will also become memory B cells and will sit around awaiting the next infection. So in terms of aging, let's talk a little bit about a secondary and a primary immune response. So the primary response, and so if we see, this is like the level of response, and I'll just put RESP for response, if you can read that. And down here we have time, and I won't try and write out the units, but let's say that this is like 21 days or something like that. All of it would vary based on the pathogen. But the primary response looks like this. You get let me change colors here so we can see this. It's going to look something like this. You're not going to do anything for a couple of days, and then it's going to come up, and it's going to go back down. And I just do this in terms of response. It could be a specific type of antibody. It could be another marker of the response, but it didn't go up real quick. It didn't go up real high, and it kind of went down soon. But now you've had your primary response, and you've developed memory cells. You have your memory B cells, you have your memory T cells, and now if you are infected by the same pathogen again, we'll do this one in a green color, here's what the response looks like. Okay. So it's quicker, right? It happened a lot sooner. It went up really early. It's of greater magnitude. See how much higher that went up? And it's longer lasting. Look at how much higher this response still is at 21 days. This is the value of having a primary and a secondary immune response. This is the value of developing those memory cells. If you've been infected with one particular strain, you shouldn't have a response to that strain again, although sometimes there's variables in there that affect that. And when I first started to teach this class a number of years ago, flu vaccines were not yet recommended for everybody. Flu vaccines were recommended for children and for elderly individuals. Well, now they're recommended for everybody. But I'm still going to tell you why, since this is a biology of aging class, why are they important for elderly individuals? And I'm going to correct my language here because over the years this has become more accepted not to say the elderly, but elderly individuals. And so we'll put that in there like that. Why for elderly, why does an elderly individual want it? Well, because of this right here. The flu affects, the older you get, and especially if you're on more medications or if you already have pre-existing conditions, the flu can affect them more strongly. And they're at a much higher risk once they catch the flu of having complications, of hospitalizations, and of death. Well, a flu vaccine can help to prevent that. And I think it's important for any student in a class learning anything about the immune system that they know the vaccines work. Don't let anybody tell you that the flu vaccine does not work. That is not true. Your friends may say that, your mother may say that, your grandmother may say that. I don't care, right? I don't care what other people say. I care what the science says. And the science says that they work. And I have some individuals say, well, they just give you the flu. No, they don't. They don't give you the flu. They give you a part of the virus so your body can make antibodies against it. That's the idea. And since your own immune system is responding, you might have some symptoms. You can run a low-grade fever. You might have a mild sore throat. You might feel fatigued and tired. That's not having the flu. That's merely your body going through this immune response. And as a result, excuse me, then you will not be, you'll be protected against that particular strain of the flu. I also hear people say, well, it doesn't work anyway because people always catch the flu. Yeah, they do. You can't, there's many, many, many different strains of the flu. Some of them are mild, some of them are more severe. And what they do in these vaccines is they try and inoculate somebody against the worst strains that are out there, the most recent strains that were out there. And if there's a new bad strain that comes out that year, guess what? It's not in the vaccine. But you are protected against those others, and that's still important. And so any, excuse me, older individual should be encouraged to make sure and get their flu shot. In fact, it is, of course, recommended now for everybody.